Algebra 2, 1.4c, collecting like terms using properties. And when terms have the same variables, they're called like terms, but their exponents must also be the same. So all of these are like terms. They all have an xy. Doesn't matter if they're a fraction, a decimal, a negative, or a positive. Because they have xy, just like this, they're all like terms, and they can be combined together. 2xy and 2x squared y are not like terms because the terms on the right here has a little 2 for the exponent for x. See that? So they're not like terms. That makes the value of x different. See? And in order to be like terms, they have to have exactly the same variables and exponents. We can use the distributive property to simplify an expression by collecting like terms. It's also called combining like terms. And they'll make equivalent expressions. So take a look at this one. We've got x, okay, ignore this dotted line. We've got x minus 4x. And because they have the same variable with the same exponent, x, there's like a little invisible 1 up here, isn't there? Do you remember that from Algebra 1? When you see x by itself, then that means that it's to the power of 1, okay? So imagine there's a little invisible 1 there, and imagine that there's an invisible 1 in front of the x for its coefficient, okay? So all this means is 1x minus 4x. It's going to give us a negative 3x, see? We're just putting them together. And if we have 3x plus 4y minus 5x minus 2y, adding an inverse to subtract, so instead of subtracting 5x, we can add a negative 5x, and in subtracting 2y, we can add a negative 2y. It's the same thing. We learned that before a couple videos ago. And using the commutative property, we can reorder them to put the y's together and the x's together, and the associative property to regroup them. In the distributive property, we get 3 minus 5 times x and 4 minus 2 times y. This is a negative 2, that's a 2. We end up with negative 2x plus 2y. See? We just put them together in their groups. So, remember that number in front of the variable is the coefficient, all right? And if that variable is by himself, it doesn't matter if he's a negative or positive, there's like a little invisible 1 there, all right? So if you don't see anything there, you have to imagine that 1 is there, okay? There's a hidden 1 coefficient there that we can use, especially when there's a negative, because then it helps us distribute the negative with that negative 1. So collecting like terms is just putting together the things that belong together, like apples and bananas. So if Emma had 4 apples, 3 bananas, 2 apples, 5 bananas, and 5 apples, we could just rewrite this as the expression 4a plus 3b plus 2a plus 5b plus 5a. And it makes sense to combine the like terms, doesn't it? Put all the apples together, put all the bananas together. So we would regroup it like this, and we'd get 4, 5, 6, and 5 is 11 apples, and 3 and 5 bananas makes 8 bananas, so she has 11 apples and 8 bananas. We use the commutative property of addition to put them in a more sensible order. We use the associative property to regroup them. See? When we see something like 7x squared y cubed and negative 2x squared y cubed, those are like terms because the variables and exponents are the same. They both have an x squared and a y cubed, so they can be combined. And this 7 and this negative 2 would make a 5x squared y cubed, wouldn't it? So our next video is going to be 1.4d. We're going to talk about inverses of sums, and I've got a couple theorems for you. And, of course, you can click on this video's description for all the previous Chapter 1 videos that we've done and anything to do with this topic, all right, to help keep you going and on your path on Algebra 2, all right? So I'll see you next video, and we'll talk about inverses of sums, all right? Bye.